Yes, this is our project called Viral Symphony. We will also be listening to the third movement today, and we'll also have a Q&A discussion at the end with the questions that you guys have submitted through the Huva app. So let's get started. I am Bilal. I am a sophomore, I guess, and my majors are music and biology. And that's kind of the reason why I wanted to lead this project is because I really am fascinated by the intersection of biology and music. So I was one of the composers, and I'm basically facilitated this whole project.
Hi, I'm Christy. I'm also a sophomore. I'm a biology major and I'm minoring in animal studies, chemistry, and French. And I helped coordinate the performance.
Hello, my name is Nila Thineker, and I am a sophomore as well. We're all sophomores. How amazing of us. Anyway, I am a psychology and music major with a minor in Spanish, and my role in this project was another one of the composers, and then I also designed the website and recorded the video and did the logistics of that.
My name is Cynthia Bashara. I'm also a sophomore. I'm majoring in biology and minoring in computer science. And for this project, I was basically coding all the stuff for COVID.
Basically, we're going to talk about the intention of this project and how we came about it and what exactly led to us making this this beautiful product of ours. So I did this project. I did a project in Dr. Todd's class. My last, I guess that was my spring of freshman year. It was a project on telomere shortening, and I did like a string quartet, and I thought this is really cool. I kind of want to do something like this, but a prolonged project, and invite other people to help me make it a really fleshed out thing. So I kind of I got this group of people, and we made this project. And one of the things that we really wanted to do was showcase how COVID-19 interacts with humans, and how we were really interested in trying to figure out how human I guess how we're going to do that through musical performance. And basically we decided to do that through electronically, that we would have COVID be the electronic component, and basically the humans or the people who are playing be the human cell. And we'll get into depth about that and basically why we're doing this.
And then another thing that I just wanted to add to this is that there was another scientist who made a audio file of COVID, and he mapped out what COVID sounds like. But the thing about that was he's a scientist and creating sounds, and that was just a bunch of sounds of COVID. But we as musicians really wanted to make music of COVID and music of these interactions, and not just produce ambient sounds, and something that actually had a musical narrative to it. So yeah.
Yes, for sure. Thank you, Noah. Okay, so basically we're going to talk about the science behind it, and then we'll get into the music. So basically we were interested in studying how a COVID cell would actually infect a human cell. And through that interaction, we were looking at the spike proteins of COVID cells. And I know you all are sure about how COVID looks like. It has the different crowns adorning on it. So we were specifically focusing on a part of the crown, of the cell that latches onto the human cell. And through that interaction, we're studying the SARS-CoV-2 S protein, which is the spike protein, interacting with ACE2 human proteins, which is a human protein that is involved in certain things. And Nila will get into that portion.
Right, so here you see the ACE2 receptor. So that stands for the angiotensin converting enzyme. And there's an ACE1 and an ACE2, and ACE2 is very similar to ACE1, except its difference is that it serves as an entry receptor for the SARS-CoV-2 virus. So basically, whenever the virus pops into the cell, it's where do I go? Where do I go? It looks for that ACE2 receptor and goes straight for it. And so that's that initial infection stage before it goes through all membrane fusion and that sort of thing. And ACE2 is also really helpful for other things. We used it before COVID happened. Our bodies just naturally use it. It helps with the ACE2 gene itself codes a protein that helps with regulation of cardiovascular function, renal function, helps with certain fertility functions as well. And so it has all of these different things in our body. And that's another thing, why there was abdominal and like digestive symptoms of COVID because there's a lot of receptors in the stomach as well. So it existed before COVID, and then now we're interested in seeing how it plays out in the actual process of the virus itself.
Sure. So I wanted to walk through what the actual music you will be hearing today is about. We are focusing specifically on the interaction of the spike protein in ACE2 through membrane fusion, which is a process that involves different conformations of the spike protein, which means different orientations to like latch on until it finds the right position in order to like actually start the process of like going through this like of COVID infecting the cell. So what you're seeing right now is like the process of which the membrane is being kind of like ripping its integral proteins and like all its structures of the COVID cell. And like you'll hear that to the piece today, that like the actual like music is kind of built upon this drama of like the membrane being tearing apart and like experiencing like I guess like some sort of like disruption. So yeah. I don't want to watch that again. There we go. And now Cynthia will talk about the bioinformatics and like how she actually implemented it, how we were actually going to write the music for it.
Okay, so there's a lot of trial and error involved in this process, and it took a while to get down because what we originally did was code just the purines and pyrimidines, which is just adenine, guanine, cytosine, and adenine, but that was just 4 letters to translate, so there wasn't enough variation there. So what I ended up doing was taking the protein sequence, which is composed of 21 letters. So that gave us a lot more variation. I used Python for this. I wanted to learn a new language, and I've been wanting to get involved in Python. So I decided to use Python and a lot of packages. But basically what it does is it takes every letter of the protein sequence and just translates it into a note of varying pitch and tempo, just to give the music notes enough variation. So at first we coded the entire COVID genome, and that was like 18 hours long, so we couldn't use that. And that's when we decided to just target the specific spike protein, so that was a little more reasonable just because the other one was insanely long. But yeah, so we just decided to do the spike protein, and that's how we ended up doing the ACE2 receptor for the human part too. So it came together really well.
And then through that music, or through that code, I guess, that we got, we were like, so what do we do with this? We have all of these letters and like whatever. So what does that actually mean for us? And like using that interaction to like demonstrate it and model it for actually something that we can listen to and understand and comprehend and that sort of thing. So what we did for that is use these lines. So we generated a line that was for the ACE2 receptor, and it was just like, that was like the baseline for that. And then we had one for the spike protein, and that was the baseline for that. And we use these as the cantus firmuses of the piece. And so for those of you that aren't in music, a cantus firmus is basically a pre-existing melody or just some sort of line of music, string of notes, whatever you want to call it, that is the foundation of the song, if that makes sense. And the rest of the music kind of builds on top of it, builds around it. And so we use those notes as the cantus firmus, and then in creating the third movement, we use like the interaction of the two and created like chordal structures and chordal models based on like the stacking of those two lines.
Right, so what Nilla was saying is that it's not necessarily every single protein is one note, like the other scientists had done previously. Bilal and Nilla worked really hard to compose this piece. It sounds really amazing. It's very contemporary, which you'll definitely see because it sounds a little bit jarring, but it's music, I promise. So the first movement is it's an electronic MIDI file, and it was for the spike protein. So that electronic sound was really just meant to show COVID and how it's foreign, as opposed to in movement 2, where we have human performers, and that represents like the human ACE2 protein. So we kind of added that human element. And then the third movement is a mix of the both. You'll definitely hear that electronic sound of COVID, and then you'll hear the rest of the performers join, and that's just signifying the interaction between the spike protein as well as ACE2. I just wanted to give like a really huge shout out to all of the performers on this piece, including the Southwestern String Quartet, which is comprised of Naomi Martins, me, we're both violinists, Stephen Lech, who's our violist, and Chase Crouch, who is our cellist, as well as Maureen Rendon. She was our pianist, and she's amazing. She's a senior, and I'm really gonna miss her. But yeah, with that, we can roll the footage.
Yeah, okay, I'm gonna have to stop sharing, and I'm going to pull up the Google Drive file. So yes, that was the performance. Let me make sure I am presenting the slideshow. So give me 1 second. Technology is a wonderful thing, isn't it? Let's do a window. Okay, I think I did it. Yes, thank you guys for listening. It means so much to us. And I also want to say, wow, the performers did an amazing, spectacular job. So props to you guys for like doing that for us. That was really amazing. So I did want to briefly kind of bring up like what like the music was about and like how to interpret the music. So the music was the actual movement, like we listened to the third movement, so it wasn't the first and second movement. We were actually listening to, remember the video I saw about the membrane like actually being fused together and ripping the things apart? That was kind of what this movement was about. It was like the interaction of the spike protein with ACE2 human cell proteins. So there are like 3 different sections of the third movement. The first movement is like about COVID. You hear like in the background, it's just like a constant like note, like dun 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 dun. That specifically is about like COVID trying to like infect a cell, like just like them aimlessly like wandering in like a sea of like you know, like just like they're not quite on like in the same position. And it also kind of brings themes of the first and second movement back into like the first section. And then the middle portion was like where the beautiful part was in, you know, how it was like really nice and flowy. That's like showcasing the different like conformations or like positions that the actual proteins can be in. So and it doesn't have the climax of the song is when it actually starts like going into like chaos, and like the moment when it happens is when it like the confirmations lock into place, and then like COVID has his solo, and then like it kind of goes downhill from there. And from the ending on, you can hear like it's really dramatic, and it's just kind of like all this dissonance happening. Yeah, and that's just like showcasing the cell being infected. And the ending is very interpretive because it was interesting because I remember Mao, our pianist, asked, so like, does the human win? Does the cell? And I think that's a really, really profound question because the ending is very interpretive because we're only looking at the perspective of like the proteins interacting. So like we know that the protein is infected, and like in the end of the day, this COVID is infecting the cell, but we don't know what happens after that. So it's really up to like interpretation of like the human dies from COVID, which I think is really powerful in its own way. Yeah. Kirsty will talk about like how she yeah, we'll get to the questions. Let's explain a bit about the music coordination part, and then we'll go into the end of our presentation.
Yeah, so the coordination part was actually not too difficult. As a quartet, we already rehearsed together in a location at the Fab, and we do that weekly. We started working on a piece with Mao as well. This is not a so much shameless plug, but Mao is actually giving her senior performance on Sunday at 2:30 p.m. It's in person, so it would be really cool if you guys could go to that as well. Yes, Mao, that would be perfect. But yeah, so the biggest thing for us was just making sure that we were following CDC protocol, especially since we were going to be in a room together for multiple hours. For the most part, we double masked. We made sure to sanitize everything every hour, and then we made sure that the spacing was right, and that there weren't more than the amount of people in our location, just due to being in a confined space. We had a fan going to help with the circulation, and we kept the door open at all times, which was both a challenge and a good thing. It was really, really hot in that room. So that was also something we had to get. Yes, and the windows chase, thank you. But regardless, it was really hot. We were in a room for a few hours. Yes, very humid. And you know, with string instruments, hot and humid's probably not the best combination, but we really made it work, and yeah, I think it came out really, really great.
For sure. And we really do appreciate Stephen exposing us.
No, for
Stephen
real,
was
though,
our
we do
biologist.
give a shout out to the performers because we spent several hours rehearsing, trying to get it all just right until we did the final take. So, like, I think it was very testing of all of our patience, but they all stuck it out, and the musicians were playing their instruments for like 4 hours straight, basically, like through a rehearsal. So major props to that.
Yeah, you guys need a round of applause just for them, like virtual round of applause. Okay, so now we've ended our presentation. We can address some of the questions that we kind of have been submitted, and then we can answer questions in the chat. A lot of things being asked about it. It's a very intriguing project for sure. But first of all, I wanted to say thank you to King Creativity for sponsoring, for like giving us a grant to actually commit to this project. And thank you, Ben, for like actually being there every step of the way and organizing this with us. Also, thank you, huge shout out to Dr. Brown, who was our mentor through this entire thing and giving us all the right like advice and giving us the right guidances on like how to like navigate through this, even through a COVID time. Like that was really helpful, and we can't like thank you enough for that. So yeah. Well, now we'll get to the questions and everything.
Cool, sounds good.
Okay. So first off, I see some questions in the chat. Maybe we can address. David Asbury asked, can you talk a little bit more about how you assign musical notes to the cell structures? So the coding was the foundation of everything. Basically, every time that a protein like was like being, first of all, we found that we like got the actual like protein structures from a database, and then we put it through the program, and then like each like individual, because there's like only a certain amount of like proteins that are like are amino acid structures that can be like made. Each one was assigned a different pitch, and those pitches were put through that were actually, that's what was the output. Like we got pitches at the end when we like put the program through, and then when we like put the music together, we put the ACE2 protein on top of this COVID cell, and that created like a guidance or like some sort of like roadmap for like chordal structures. So like actually like gave us some sort of like direction on what we wanted to do. Other than that, there was a lot of flexibility on like what the rhythms were and like how we wanted to do it. But the main thing was we wanted to keep the notes there. The notes were the most important part, and making sure that like there was some sort of idea that like, because the fun thing about it was the proteins, there would be moments where there was like, you can't avoid dissonance. Like the nature or the environment of the music itself is just set up to be like hard to write music for, and like we wanted to embrace that part of it. So I hope that answers the question.
Sorry, I was gonna add that when in the parts that I was composing, I composed it a lot like counterpoint, because that was kind of the focus of study for like music theory 3, which I'm in now. And so we just did a lot of counterpoint, and so that's kind of using each different note and each all the words, each note as a different like baseline for it, and then building all around that. And that was kind of where the cantus firmus and that sort of line of thinking came from for that.
Yeah, does anyone else want to add on to that question before we move on? Okay. So another thing, a question we got asked in our like Huva thing, which is like where we had the King Creativity like show, like, never mind, you know what I mean. One of the questions was, do you all anticipate engaging in similar collaborations in the future? That is a very interesting question. I think Nelly, you should answer this one because you have the answer.
Okay, I have the answer apparently. Well, actually, I want to do more with this because I feel something I personally feel really passionate about is like the field of public health in general, and just giving people information about these scientific concepts and all of these things that are, really important, but are almost like kept away from people, or, you just get as like the general public, you just get like a little overview or like the quick facts of it, but, kind of breaking down these viral structures and like what each of these means. And like just showing people that you can learn about complex scientific topics, and you don't have to be a biologist or in science or in college or anything really. And so this is just a way for people to see like, oh, this is the interaction. We can look at this website. We can look at an animation. And so I personally want to do more work in this area. I don't know if it'll be exactly about COVID. Hopefully we like move away from having to worry about COVID in general at all as of anything. So yeah, maybe not COVID exactly, but definitely a lot more public health. And obviously as a musician, I would like to work that in wherever I can. But yeah, definitely I feel strongly about doing more work in public health. And I think as a bunch of pre-med students, I think the others do as well, hopefully.
I also wanted to add, our original plan for this project was very ambitious. So we actually had planned to do more performances. So we actually, now that we have like the foundation, we could technically write more music because that's what we were planning on doing. It's just a matter of if we want to do it at this point. So we just have to figure out what our plan is. We'll keep you guys updated because it seems like you guys are very interested about that. Before I go back to like the Q&A questions, is there anyone in like this space right now want to unmute and ask a question that they may have? Anyone want to like say anything, like comments?
Well, I wanted to add on to what you were saying a little bit earlier, Bilal, about just us being very ambitious at the beginning. Originally, Bilal wanted to write for a 4-person vocal. I'm sorry, I don't really know what it's called. I'm not a vocalist. Yeah, he wanted to do like a small group of vocal performers, but we ultimately decided against that due to COVID. So we just had to be very mindful about the arrangement in which we were writing for, and what was possible during this pandemic.
Sure.
So yeah, I guess in the future we would have more opportunities for like maybe adding in some brass or vocal or other instruments, other things. Maybe this will be a series that continues. Tune in next Research and Creative Work Symposium 2022 to see. I'm just kidding. Don't hold us to that. We don't know yet. Maybe.
Yeah, because now that the program is finished, you can pretty much plug in any protein sequence into it. So any other viruses or variations or really anything can just be plugged into it and it'll spit out a MIDI file with everything you need to go from there.
Wow.
Definitely future stuff that can be done with it now that it's done.
That'd be really cool. That's really amazing. Dr. Asbury, you wanted to ask?
Sequence the vaccine next and do something that's super, like, you know, healing in a way. So that would be my recommendation if you guys take another step. But it was lovely, really, really well done. Enjoyed it so much. It was great all the way around. So thank you very much.
Thank you, Dr. Asbury. That really means a lot to us. And that's actually a good idea too. The problem is, oh, sorry, Nila, do you want to say anything? I was just gonna say, the main concern I think was that like I don't know if like Cynthia probably figured out with their coding because like Cynthia's a coding queen at this point now. We had a problem because we only had like certain like things we could access through the database, and we couldn't find certain things unless it was public and like that we actually had access to. So it comes down to like actually like if we're able to get that, because you know how like secretive like that can be probably. I don't know if it is, but let's call it CDC real quick.
It's for a good cause. Listen, Center for Disease, do you want to support undergraduate research or not? Or not? I'm sure they'll give it to us if we ask really nicely. Send them a nice professional email. Sign it with our names.
Send a recording of this.
Yeah, actually, that's true. Does anyone else want to ask anything?
So I was just going to say, if anyone does want to learn more about the other movements and give those a listen, we also have like explanations of like each musical thing and what the movements are for the first 2 movements. Here's the website if you'd like to go look at that. And we'll be putting the recording of this as well as the performance on the website for if you want to reference it later, show your friends how cool and amazing our project is. Anything. So there's a website for y'all.
Amazing. feel like we're ending towards the near of our lovely presentation. Obviously, we are very passionate about this topic, and we could talk about it for a long time, but I don't want to keep you guys for long. So thank you so much for coming to our presentation. If you do have more questions, access the Whova app, or even just contact us. Like, we'll answer them. Like, we love having the conversation about this because we've been working on this for like since October, and just finally getting that like collaboration like happening now is what we really wanted to do since like we started this project. So thank you guys for coming. It was a really awesome time, and I hope you guys are safe and well. That's all I have to say. Thank you guys so much. I hope you guys have a good rest of your day. We shall see you later. Bye-bye, everyone.
Thank y'all.
Thanks for coming. Bye, y'all.
Thank you for coming.
Thank you.